Hey everybody, in today's video, I decided to try to figure out how to calculate the total number of flights that travel over each state in the United States. This is a pretty interesting question. At first, I was a little bit bewildered about how to approach the problem, but I did some research. I found some airport data, some FIPS data that has state IDs. I found some GeoJSON data, it's called, that has boundaries of states and counties within those states. So it was a pretty interesting problem. I sat down, thought about it, tested some ideas, found a few data science techniques that seemed appropriate, and put together what you see right here, right now. So we can calculate distances between airports given the airport latitude and longitude, and the destination airport same longitude and latitude. Longitude and latitude, right? So we can find the distance between those using the haversine distance technique. Let me go ahead and run this. I have the file saved on my desktop. I'll share the file with you when I post this this video a little bit later today. I'll share the link to the source data at the bottom of this Jupyter notebook, and I will supply this to everybody. So anyone that watches video, you can go ahead and download this file. I'll save it as HTML. You can download it, double click the file, and you'll see the same view that I see here. It's a Jupyter notebook. I do all my work and all my developing in Jupyter notebooks. I like it because it's pretty interactive, especially the plots and the charts. You can zoom in, zoom out, mouse over, see the pop-ups, see the tooltips, scroll left and right, up and down, back and forth. So very interactive, very visual, and really pretty powerful stuff. A good alternative probably would be a Spider IDE or JetBrains. That's another Python tool that's pretty popular. I like these Jupyter notebooks though, mostly because of the fact that you can create these interactive charts and plots. You can create little widgets that you can scroll back and forth, zoom in, zoom out. So it's very interactive. It's very easy to use and pretty interesting too. Okay, so we loaded our records. I think we have about, let me see what this is. 10 million, 1 million? Yeah, about 1 million. About 1 million, just over a million records. It's a little bit slow. I truncated this to just take a sample of 500. So I'm taking a random sample of 500 because to load all 1 million and to run this analysis on 1 million on my laptop, it's just not going to happen. I could maybe get a couple thousand max, but I think 500 random sample is good enough to illustrate the point of what we're doing here. If I had a more powerful machine, I could probably get the whole data set, but today I cannot do that. So we could visualize the data. We see airport, destination, origin, airport, origin, or origin, destination, airport, destination, city, passengers, flights, flight dates, destination population. I don't think that's super important. But then we have the latitude and longitude coordinates. Those are super important, right, for calculating our haversine distances. And let me see what we came up with. Okay, so we had the original airport, lat long, des airport lat long, and the distance in kilometers was derived from this haversine distance formula. So it's pretty straightforward. You can Google this. You need the origin lat long, destination lat long, and you combine it into this haversine function right here, and it does the calculations. Pretty straightforward. So let's move down and take a look at the next step here. Now we have a Folium plot. I'm looking at the origin lat long, destination lat long, and I'm going to use a Folium marker to show me the origin and the destination, and color shall be blue in this case. I think this is fine. It's going to illustrate the point. It's going to show us all those airports. Probably most of them are located in big cities, almost without exception. We're going to be in some kind of metro area, and we are going to see the blue dotted line showing the flight path between the cities. And I think I zoomed out a little bit too far here. Let me zoom in just a bit. Okay, so you see the whole world. We're just like at the U.S. Trying to get this going. My computer's been running slow all week. I have no idea what's going on here. It's fine. It's fine for the past year, and then all of a sudden, start recording some videos and it goes super slow. So here we have the origin. We can put the mouse over, gives us some details about this, and it just shows us a nice visual plot of all the airports in the United States, right, and the flight paths between them. So that is pretty cool. Let me Zoom out a little bit. Great, so we have haversine distances, we have all the flight paths. The next thing to do now is to look at the GeoJSON data that I talked about just a moment ago. This shows us the state boundaries. You have two types of GeoJSON data. You have state boundaries and county boundaries, right? So all the counties within each state and then all the states within the United States is represented in these files right here. And I don't know why it's so laggy. This is a little bit annoying. Okay, now it's back. So we have the airport and the state data. So we can get the state boundaries. Let me go ahead and refresh this. Control Enter to run it. And then we can see the basically the details or the geometric lat-long coordinates for all of these airports. Okay, so continuing on. We are going to go ahead and calculate the flight path now, and that's how we're going to determine which flights are going over which states, and then we're going to take account of all the flights going over all the states. We're going to see what the top 10 flyover states are, okay? So if PD is in row, there's two ways to do this. Origin, airport, lat-long, destination at lat-long. But I'm saying is NA. So if there's is any NAs, that means not available, okay? If that's not available, then just do nothing. Otherwise, give me the origin airport, lat-long, and the destination airport, lat-long. So you could do this two ways. You could say if PD is in or string contains, strcont or ISIN is in, then give me the origin and destination. So some of these might be missing. That's why I'm doing it this way. If you don't have, if you're sure your data isn't missing any rows, then you can just do it. Go ahead and do the calculation. If you think it might be missing some, or if you know it's missing some, you're going to have to do a test, like a try and accept. So if there's an exception, you skip down here and you'll just say, okay, there's an error on this row. Let's process the row, but keep going. You don't want the code to fail. You don't want to just stop and get derailed. You want it to keep going. So that's why we have a try accept clause right there. So now we are getting the flight paths and we need the FIPS to state. So FIPS is a state code number. So 01 is Alabama, 02 is Alaska, 04 is Arizona. I guess some of these are getting skipped. I'm not sure why. This is just the way it is. And you can see there's 56 of them and there's 50 states. So some numbers are being skipped. I'm not sure why this was set up, but this seems to be the convention. So we have the FIPS to state, we have the flight path, and we have all the lat-long coordinates for destination and origin, right? So we can go ahead and commingle everything together. And then I have a list here called state names, and I'm appending the state name to this list as this function runs. Okay, so is there anything else we need to be aware of? All states for state and sublist. Okay, so here's one more small loop just to finish this off here. For state and sublist, if state is flyover state, we are adding that to all states, okay? And then we have state counts. And we're getting a value count of that. So that's how we're summarizing all the flyover states based on the FIPS to state and the GeoJSON data that I showed you before. So let me go ahead and run this. And again, this data is truncated. I think now we're looking at a sample of 2,000. In the first example, I was just plotting the flights, and that chart tends to run a little bit slow, so I set that to 500. I thought this was 2,000. Let me see if I could find this. Maybe it's 5,000. In any event, it's not the whole million because this is just going to be way too slow. It's just not going to run for me. I'm not seeing it, but this is a subset of the original 1 million records, right? If it's just too big, it's not going to run. It's just not going to happen, right? So we have to live with what we've got here. So some of the FIPS data seems to be missing, and I wonder if it has to do with these codes, Alaska, Arizona. No, I don't think so. I think they just use that convention 1, 2, 4, and they skip 3. But I think the FIPS data is missing something because we're finding 833 unknowns. So this is a good old case of garbage in, garbage out. We're not paying for the data. It's all open source. It's all free. So There's probably some mistakes in there. I can't vouch for the airport data, how clean or how validated that is. I found the file online. It looked reasonably and to be in decent shape, so I just grabbed it and went with it. So we do have some mismatches here where we can't match FIPS to the GeoJSON data, and that's unfortunate, but it is what it is. We're still getting some good results here, and if I scroll down a little bit more, we should have a nice, clean final count of Michigan 243, Florida 226, Illinois, Toronto the top 3, 195, and the top 10. We see Virginia has just over 100, Alaska, and then Connecticut coming in with 63, and all these other states are less. But again, that is a subset of the larger set of data. So I just was curious where that subset was coming from, because I saw that recently. I put this together about a week ago. I'm not seeing it, but I did see the 500. But clearly we're working with way more than that, because we had 833 for the unknowns. Yeah, I think it's below. Yeah, there's the 500, a sample of 500. That's what we're doing for the maps. But I could swear we had 2,000 for that second analysis of the FIPS data. But I'm just not seeing it. Oh, wait, there's one. There's one. Oh, yeah. So another random sample, 2,000. That's what I thought. Did this like a week ago, and I forgot. So we are getting a smaller subset of 2,000. So this final report that you get at the end is based on just 2,000 flights, right? And we have like 833 or so that we can't match up. So these numbers are way smaller than what we saw in the 1 million original file, the original CSV. But again, the laptop is just not that powerful to be able to do those big calculations. You need something like Spark or Databricks would do it, right? Databricks is sort of similar to a Jupyter notebook, but way more scalable and has way more RAM, and it scales over many clusters of machines. Right now I just have one single machine doing this, so it's a little bit overwhelming for my laptop, but we got the results. We proved the point and illustrated how to calculate number of counts of flights going over each state. And here is a link to the source data. So I'm going to save this file in just a minute here, post a video, and I'm going to post this file along with the video, so you don't have all this source code. You can copy paste it, run it in your own Jupyter notebook, and see how everything works. I think it's a pretty cool exercise. It gives you good insight into lat-long coordinates, haversine calculations, FIPS data, and then calculating distances between lat-long coordinates. So it covers a lot of topics. Hopefully that was enlightening and useful for you. Thanks for your time today. Have a great day. Bye.